Thank you very much for the short introduction. I'd like you to welcome to my presentation with the title Cerebral Oxygenation Delivery Does Not Limit Exercise Performance in the Heat. So it has been mentioned several times, but I will say it again. When exercising in the heat without prior heat acclimatization, a reduction in exercise performance is an inarguable fact. But the question regarding this decrease is still not completely answered. Neubaugh et al. Were first to provide the idea or to raise the idea that maybe a decreased brain blood flow might be the underlying mechanism for this hampered exercise performance. And this marked decrease in brain blood flow appears to, at least partially, be triggered by hyperthermia-induced hyperventilation and the concomitant decrease in PaCO2 in the blood. This in turn leads to a decreased middle cerebral artery velocity, since we know that this middle cerebral artery velocity is mainly influenced or regulated by the PaCO2. At this point, I think it's quite important to mention that the middle cerebral artery velocity can be considered as a good representative of brain blood flow. So in the future, when I'm talking about middle cerebral artery velocity or brain blood flow, I mean the same. And so we stopped at the assumption that a decreased brain blood flow is the responsible mechanism for the decreased exercise performance in the heat. And to answer this hypothesis, the aim of our study was to artificially prevent the drop in PaCO2 towards the end of exercise by adding small amounts of carbon dioxide to the inspiration. Therefore, we expect to prevent a decrease in brain blood flow as well, and therefore hypothesize that this would lead to an increased exercise performance compared to a normal control heat trial. Therefore, 8 moderately trained male subjects were recruited to participate in the study. They performed a maximal incremental exercise test under 3 different occasions. The first one was conducted at 18 degrees ambient air temperature, the second at 38 degrees ambient air temperature, and the third one as well at 38 degrees, but with small amounts of carbon dioxide added to the inspiration. The humidity of all the 3 trials was kept around 40%. And now to induce hyperthermia without a prior or without employing exercise, which could act as a potential confounding factor, subjects were immersed into a 42 degrees water bath before the heat trials. And they sat there for around 30 minutes, and thereby rectal temperature was raised by approximately 1 degree. And of course, to keep the protocol standardized, subjects were as well immersed in a water bath before the control trial, but there the water was thermoneutral to keep core temperature stable. And after this passive induced heating, subjects were immediately transferred to the climate chamber where the maximal incremental exercise test was conducted. And now let's go straight to the results. What you can see here, you can see a graph of the PaCO2 value of the control trial. So, as expected, toward the end of exercise, we found a decreased PaCO2 in the blood. The PaCO2 in the heat trial showed a similar graph, but was significantly reduced compared to the control trial. And when having a look at the heat plus CO2 trial, we can see that indeed we were able to successfully prevent this drop in PaCO2 toward the end of exercise. When looking at the brain blood flow, we can see the concomitant reduction in brain blood flow towards the end of exercise. And again, when having a look at the heat trial was significantly lower compared to the control trial and showed as well this decrease towards the end of exercise. And finally, when having a look at the heat plus CO2 trial, Again, we can see that we could not just successfully prevent the drop in PaCO2, but as well in brain blood flow. And now, originally I planned to show you some data, some NIRS data from the brain representing cerebral oxygenation. But unfortunately, due to two factors, we came to the conclusion that these NIRS data might be not representative. First of all, we could just include very few subjects in the heat trial. Due to the very high sweating rate, it was almost impossible for us to get a good and continuous NIRS measurement. And secondly, it has been recently shown that NIRS data collected in the heat are by almost 40%, they are influenced by the increased skin perfusion. And so this gives us some indication that these NIRS data most probably show more the skin perfusion than the actual cerebral oxygenation. But nonetheless, when looking at the graph, it gives us some indication that we could, at least to a certain amount, preserve cerebral oxygenation with adding small amounts of carbon dioxide. When looking at the maximal incremental exercise test, we can see that VO2 max in both hyperthermic trials was significantly lower compared to the control trial, but they did not differ from each other. So in other terms, with adding small amounts of carbon dioxide, that did not, or subjects were not able to achieve higher VO2 max results, and therefore most probably had not a higher exercise performance. Therefore, we can, as a summary, we can say that we were able to successfully prevent brain blood flow from decreasing towards the end of exercise. Nonetheless, this does not lead in an enhanced exercise performance, and therefore we could conclude that exercise in the heat is not limited by a decreased cerebral blood flow. So there must be other mechanisms. Professor Gonzalez Alonso showed us some possible mechanisms, and I hope after this conference I will know them all. So since I haven't seen the red card, I think I can shortly express my gratitude towards the whole Aspetar committee for the hostility and for giving me the chance to present in front of so many experts. And furthermore, I'd like to thank my supervisor, Professor Dr. Carsten Lumpi, and some collaborators of our lab. And last but not least, thank you very much for your attention. With Cosmet. So it is.
Tidal. Did you correct it all for tidal volume for 8A differences? Did you do correction?
Yeah, we used the correction factor formula for correcting this PA. Actually, we measured PaCO2 and then used a formula given by.
Because I was wondering, at rest you got a PaCO2 of 32 or 33, and you normally think of that to be about 40. And then with increased exercise, as you increase your respiratory compensation, usually PCO2 will drop. Because as your VE to VCO2 goes over 25, which you get with respiratory compensation, it would drop. So I was just wondering, at least in my eyes, that looks a little low to start. Yeah. And this is incremental work, right?
Incremental.
So I was wondering why they were going up.
Why they were going up, or?
Going up, yeah, because I would have guessed that they would have started around 40 and then they would have dropped.
I mean, the first measurement point is at rest, and I think it makes sense that it increases then with initiating the exercise. And we could see this slightly increase during the first period of the incremental exercise test.
I'll talk to you afterwards.
Well, thank you for the presentation. That was nice. Now I don't have to do that study to convince people that the decrease in cerebral blood flow, because I perfectly agree that the decrease, at least when you're euhydrated, and maybe also under these conditions, is within a limit where increased extraction of oxygen in the brain can compensate, so you can maintain your cerebral blood flow. And I would say that, and that you possibly should look at, because I agree that the resting values are a little low, and maybe people are hyperventilating already a little bit there. But I would say that since you managed to restore the cerebral blood flow, I'm pretty convinced that you created conditions where you, with the amount of CO2, corrected arterial CO2 back to its normal level. So I would say that I'm satisfied with that. Did you adjust the amount of CO2, or did you just apply a constant?
No, we adjusted. Yeah, we continuously recorded PaCO2
so
and then adjusted
increased
accordingly.
more and more. Yeah.
Yep.
And we actually see the same in slightly different, but for prolonged exercise. Again, the article that I was mentioning before, where we restored cerebral blood flow. And it was submaximal exercise, but we couldn't, the RPE or the endurance could not be restored. So I perfectly agree with your overall results. But it's clear that for publication, you should look at because if you stick a mouthpiece into the mouth, some subjects will hyperventilate at rest. So maybe you should look at the exercise responses. They're more clear and nice. But
I will definitely have a look at that. Yeah, thank you very much.
But nice study.
Quick question. Just with cerebral blood flow, it looks from at rest that there's already an offset within the conditions, with the cold condition being higher. How did you standardize the measurement site? And did you measure it? Because I'm assuming that this offset might be due to being heated prior to exercise. But did you measure before exercise the site to make sure that it was the same site and same blood flow?
Yeah, of course, we always measured at the same site. Yeah, we marked it, and yeah. So yeah, I mean, of course, from child to child, it always has kind of a variation, because we could use permanent marker that lasts for 2 weeks or so. But we always wrote down baseline middle cerebral artery velocities and the depth where we measured, and all that variables, and checked that they were always the same at baseline. So.
Other questions? All right, thanks very much.
Right.